A splitting loads function was introduced in X5, but in X6 we have two more splitting functions to speed up the work. First, we define loads, which we will split by stories. So we place the same load on each slab, drawing the rectangle backwards to select the intersecting domains. We set the desired load. Then we create a load group for the generated load cases. We'll call it live.stories. Okay. Then we split the loads of the ground floor according to the structural grid we have. That will be the second issue. Now we just split these loads, placing them into individual load cases. As I check that, remove the loads from the current load case, the loads will disappear. But if I go to the newly generated load cases, we see that we have 4 load cases with loads on the individual stories. Now we display the ground floor only to show the other function when we split loads according to the structural grid. We have 2 types of splitting pattern, field by field and the chessboard pattern. We create load groups for these. So first we will check, we enter root for the generated load case names. We place load cases to this load group and set the chessboard pattern. And let's check it. We go to the ground floor 1 and ground floor 2. So these are complementary patterns. We can check it if the whole of the domain is covered. We can check it by setting a special color coding for this type of loads. Okay, everything is covered by loads. If so, overlapping loads would appear in the color coding. Now we do the same, but in this case we split the loads field by field, so we will have as many load cases as fields. That's a greater number. So we generated as many load cases as the number of total fields. This splitting can also be checked using color coding. This part shows how to change multiple loads with the same intensity in one step. That's the question. We have same loads on certain elements and we want to change the value on all elements with -3. So we select the component, extend the selection to the same value and change to -4 to -4. That's it. In one step. We do the same with the inside purlins, -6, extend the selection, change it to -9 on both ends. That's it. It's the fastest way to do this. For concentrated beam loads, it works just the same. We extend the selection and replace -2 by -3. We select inside purlins -6 to -8. And it's much the same for surface loads. We select one, extend the selection and change the value.